my dear students. In today's lesson, our objectives are to trace and explain the energy transformation in various activities. Second is to ascertain that the total mechanical energy remains the same during any process. I hope you enjoy our lesson for today. Let's start. Energy is involved in all life cycles. In fact, we can observe energy in everyday life. We can see energy in different forms, such as the need for solar energy to grow plants. The food we eat contains chemical energy that, once consumed and processed, becomes a mechanical energy that allows us to do the things we need to survive. Now, energy has two forms, namely potential and kinetic energy. Potential energy is defined as an energy in matter due to the arrangements of its parts, its composition, location, and structure. It is commonly considered as a stored energy, having the potential to do mechanical work. The various forms of potential energy are gravitational and elastic, while kinetic energy is defined as an energy in moving matter and wave. Some forms of kinetic energy are motion, radiant, sound, thermal, and wave energy. Now let's take a look at the potential and kinetic energy equation. We have the table here, and for the potential energy, we have two types, the gravitational and the elastic. The equation for the potential energy gravitational is equal to mgh, which m stands for mass of the object, g for the acceleration due to gravity, h for the height or elevation difference. And for our potential energy for elastic, we have the k squared, where K is actually the spring constant and X stands for the compression or extension length. Now we also have the equation for the kinetic energy. This is equals to 1/2 mv squared, where m represents the mass of the object, just like the potential energy, and we have the v, which represents the velocity of the object. It is important to note that energy cannot be created nor destroyed. This means that it is impossible for us to create energy. It is given. There's always a source, and at the same time, we can't destroy it. However, it can transform into a different form. We call that energy transformation. Energy transformation involves energy input, which is the source being processed, converting it into a different form of energy. Let's look at this example. In generating energy, we deal with the source of energy, like an automobile, using gasoline. Gasoline is a form of chemical energy which is processed by the engine, converting it to mechanical and heat energy. Another example, we have a thermonuclear reaction changes nuclear energy to radiant and heat energy. We have a tree changes radiant energy to chemical energy. Next, we have an electric mixer changes electrical energy to mechanical and heat energy. Another one is hammering a nail changes mechanical energy to deformation and heat energy. And lastly, this is what we do every day, a lamp changes electrical energy to radiant and heat energy. So again, with the example given, energy cannot be created nor destroyed. However, it only changes from one form to the other. This picture will show the relationship of kinetic energy and potential energy. The relationship is that potential energy can transform into kinetic energy and vice versa. It is important to note that potential energy is a position relative. This means that the higher the object is, or the higher the location of an object is, the greater the potential energy. While for kinetic energy, it changes depending on the object's speed and its mass. Now let's now examine what happens to the mechanical energy of a roller coaster. The cart is originally located at uh, point H, wherein it is not moving, so it obtained a potential energy given its position with zero kinetic energy because it's not moving. Now, as the cart moves from location H to location O, the potential energy decreases, given again because the position change, and at the same time, since it's moving, it has already a kinetic energy. So if you notice the graph here, we have potential energy and we have kinetic energy for this particular position. Now, as it goes up, it gains back its potential energy because again, it's a position relative. So the cart goes up, it will obtain its potential energy because of the position of the cart. And since it's going uphill, the speed is slowing down, therefore its kinetic energy is now decreasing up until it reaches the top. As it reaches the top, the cart stops. At this time, potential energy is obtained while kinetic energy is at zero. So if you notice the overall scenario in here, there is an exchange of potential energy and kinetic energy. So there's mechanical energy. If we summarize everything again, at the top of the hill, the cart is stationary, so the car begins to move down the hill. The potential energy begins to be converted to kinetic energy. The cart gathers speed until it reaches back on top of the other side of the hill and converts the gain kinetic energy back to potential energy. The previous scenarios would tell that mechanical energy is an exchange of potential energy and kinetic energy. Potential energy is a position relative, while kinetic energy depends on the mass of an object and its velocity. Now, ignoring frictional force and other external forces, it says that the total mechanical energy, which is the sum of the kinetic and potential energies, remain constant at all points in the track. In the equation form, let us prove that mechanical energy total 1 is equals to the mechanical energy total 2 is equals to the mechanical energy total 3, and so on and so forth. So if the value is constant, and as you all know, mechanical energy is actually the sum of potential energy and kinetic energy. So it would be equal to the potential energy and the kinetic energy of an object in a specific given time. Now, let's solve a problem. Consider a 1 kilogram stone drop on top of a hill and reach the ground after 3 seconds. From your concept on free fall, the height of the hill can be computed using the formula. Height is equals to 1/2 acceleration due to gravity times time squared, the velocity, which can be computed as acceleration due to gravity times time. And for our initial velocity, since this is a free falling object, it would be zero. Now let us determine what happens to the free falling object's kinetic energy and potential energy. At given time, which is 0 seconds, the object's height is 44.1 meter from the ground. So we will use the potential energy for this given. So potential energy, in our previous slide, the equation is equals to mass times gravity times height. We all have this given here. So our mass is 1 kilogram stone. Our gravity is a constant uh, value, which is 9.8 meter per second squared. And our height, again, before this guy here dropped the stone, its height is 44.1 meter. So we multiply those given, and that would give us a product of 432.18 joules. This is our potential energy. Again, this is when the guy hold the stone. So it's 0 second with 44.1 meter height from the ground. Now, let's take a look at kinetic energy. Again, time is 0 seconds, same with the given time earlier. So to calculate kinetic energy, based on our previous slide, we have kinetic energy is equals to 1/2 mv squared. 1/2, we simply substitute 1/2 times 1 kilogram. This is the mass of our object. And since the guy at 0 second didn't drop the stone, therefore its velocity is 0. So we multiply those given, and that would give us a 0 joules for its kinetic energy. Now, to solve for the total mechanical energy, we simply add potential energy and the kinetic energy. So at 0 second, the total mechanical energy is equals to 432.18 joules. Now, since we already have our value of the potential energy and the kinetic energy and the total mechanical energy at 0 seconds, for this scenario, the boy dropped a stone in a cliff. So again, we are going to prove that mechanical energy total 1 is equals to mechanical energy total 2, and so on and so forth. And since mechanical energy is the sum of the potential energy and the kinetic energy, we will also prove that potential energy 1 plus kinetic energy 1 is equals to potential energy 2 plus kinetic energy 2, and so on and so forth. Now, for our second scenario for our problem, it will be at 1 second. Okay? So again, earlier we were able to solve the problem at 0 second. This is our potential energy value, kinetic energy, and this is our mechanical energy total. Now, at 1 second, the potential energy is what? What happened after 1 second? So our equation is potential energy is equals to mass times the gravity times height. We have that already. So we have 1 kilogram for the mass of the stone, our constant value 9.8 meter per second squared. And for our height, it's 39.2 meter. Now, how did we get 39.2 meter? Now, that's simply 44.1 meter minus 4.9 meter. 44.1 meter, this is actually the original height value of the stone from the ground. Before the boy dropped the stone, it has a height of 44.1 meter minus 4.9 meter. How did we get 4.9 meter? Now, remember, for a free falling object, we have this equation. Height is equals to 1/2 times the acceleration due to gravity times time squared. So we simply substitute. We already have our acceleration due to gravity at constant value, which is 9.8 meter per second, times our time. Remember, it changed from 0 second to 1 second this time. So this is 1 second squared divided by 2, because we have 1/2 here. So we solve this one, that would give us 4.9 meters. So from the original height minus the 4.9 meter, that would actually give us 39.2 meter as the current height of the stone after dropping in 1 second. So we simply multiply, that would give us an answer of 384.16 joules. This is our potential energy at 1 second. Now let's have our kinetic energy. So for kinetic energy, we have 1/2 times mass times velocity squared. So we simply substitute. We already have 1 kilogram for our mass. Our velocity is 9.8 meter per second. Now, how did we get 9.8 meter per second? So for, again, free falling object, we know that the acceleration is constant at 9.8 meter per second squared. So our problem is to determine its velocity. And we can get the final velocity by multiplying acceleration due to gravity times time. So we have this value already. So 9.8 meter per second squared times 1 second. So that would actually give us 9.8 meter per second. That's our velocity, final velocity after, again, 1 second. So we simply multiply. That would give us kinetic energy, a value of 48.02 joules. So since mechanical energy is the sum of potential energy and kinetic energy, then we come up to this 384.16 joules plus 48.02 joules is equals to 432.18 joules. Now remember, we already have here kinetic energy, because the stone is actually moving after 1 second because the boy dropped it. And if you notice our potential energy, it decreases from 432.18 joules when it was not moving to 384.16 joules because there is a height difference. Remember, potential energy is position relative. Now that we already have our mechanical energy, let's try to compare. Because again, the main reason why we have this problem is to prove something, if this concept here is actually true. So we have mechanical energy at 0 second is equals to mechanical energy at 1 second. So we have this one, 432.18 joules is equals to 432.18 joules. So definitely this concept is actually correct. Now, remember that energy can't be created nor destroyed, so it is important for us to use the energy wisely, as there are some energy that is non renewable. We all want to enjoy what we have now, but we hope that this will not compromise the chance of letting the next generation enjoy what we also have.